Okay, topic 9 is called integration by substitution, but we're going to do a whole variety of different things. Sometimes we're substituting, sometimes we're rewriting. This is where we'll use our trig ones. There's several different kinds of problems. We're going to look at several on this particular topic. Okay, first, just straight substitution problems. We're going to evaluate the following. Now, on this first one right here, notice how we have x squared up here. If I take its derivative, I'm going to get 2x. 4x is a form of that derivative. That tells me my substitution. I let u equal x squared. Take the derivative, I get du equals 2x dx. So, some of you like to go over and actually solve this out. You may do du over 2x is equal to dx and actually see the canceling. If I do that, I'll get the integral of 4x times 2 to the u times, now I got to replace dx, that was du over 2x. X will cancel. I'm going to change colors real quick. The x's cancel. The 4 and the 2 cancel. That becomes a 2. And we end up getting this result. A lot of you can just simply do that. We had to realize, okay, I got 2x dx. I have 4x dx, so I got 2 left over. Just move the 2 to the outside. Better know your antiderivative for your exponentials. Remember, the antiderivative of 2 to the u is 2 to the u divided by natural log of 2. Watch out, a lot of you take the derivative of that. So I got 2 times 2 to the u over natural log of 2 plus c. Replace the u, and there's your final answer. Watch out for AP test questions, because I would not be surprised if they wrote it as 2x squared plus 1, because that's 2 to the first over ln of 2. Just got to be ready for weird manipulations. It's not really that weird of one, but it's a common one. Okay, the second one right here, this one you got to do a little bit of manipulations, because the substitution is just so we can do the problem. So if you see something like this where you have something that can be basically thought of as in parentheses, make that substitution. Let u equal x plus 3, du equals dx. Now what I've got to do is write everything in terms of u. Well, I've got the u inside the square root, but I've got to replace the x with something in u. So I solve for x, and I get u minus 3. Plugging in, you get u minus 3 times u to the 1/2. If I multiply that in, remember that's u to the first times u to the 1/2 will give me u to the 3/2 minus 3u to the 1/2. Now I do my antiderivatives. It's u to the 5/2, then times 2/5 minus u to the 3/2 times 2/3. Remember how we take the reciprocal when we're dividing by a fraction? It's much easier that way. 3's will cancel, and then plug in. So this is the ones we're dealing with basically substitution techniques. Also on this topic, though, we can do the trig ones. So I love the first one. This is a very common kind of a problem, so I want to make sure you're ready for this particular one. This is where you have to realize it's a form of tangent inverse, but it's not written in the correct form. I have to have a 1 in front, so I'm going to factor out a 4 from the top and a 4 from the bottom. When I do that, I've got to take the 9x squared and divide it by 4 as well. Now it's still not in the correct form because I've got to get it 1 over 1 plus something squared. So that becomes 3/2. And I could use substitution right here, but at this point, I think most of you are comfortable with the idea of compensating for the chain rule when it's linear. Okay, so we get tangent inverse of 3/2 x plus c, but because I've got chain rule, if I took the derivative of that, I'd have to multiply by 3/2. To compensate, I multiply by 2/3. And that gives me an answer. It makes it a lot faster, too. The other example is a common one that you guys are going to have to be comfortable with, because I will put this on SIG test. This is a question of memorizing. Then when you have sine squared or cosine squared, you're going to have to write it in terms of cosine of 2x. If it was cosine, the sign is plus. Cosine is the same as cosine. If it's sine, it's going to be the minus. So memorize this relationship. It's 1 minus cosine of 2x over 2. I'll factor out the half. Take the antiderivative. I get 1/2. Antiderivative of 1 is x. Antiderivative of cosine is sine. So I get sine of 2x, but I got to compensate for the 2x, so I divide by 2. Distribute in. That's probably your final answer. It's okay if you have the answer, this first answer. This is okay. That's correct. or you might have the other answer afterwards.